Section 8.3, Day 1, we are adding rational expressions. The essential question: how do I add rational expressions? Please write that down. Adding and subtracting rational expressions is similar to adding and subtracting fractions. To add or subtract rational expressions with like denominators, we add or subtract the numerators and use the same denominator. For example, 1/5 plus 3/5. The denominator stays a 5, and we add the 1 and the 3. Same thing here, 6/7 minus 4/7. They have a common denominator, so therefore we just subtract the numerator. 6 minus 4 is 2, 2/7. We're going to be doing the same thing, but now instead of very basic fractions, we're going to be dealing with rational expressions. So example 1, it says add or subtract. Identify any x values for which the expression is undefined. We've already done that part in previous videos. It says add or subtract. Well, obviously we're adding because there's a plus sign. Because the denominator of this fraction is x plus 4, and the denominator of this one is also x plus 4, it makes our life real easy, because all we have to do then is write the denominator, x plus 4, and then in the numerator, what I'm going to do is put everything together, x minus 3 plus x minus 2. So we add the like terms in the numerator. 1x plus 1x is 2x. Negative 3 minus 2 is a negative 5. And there's our answer. And this is our denominator. And so we have to specify what x values will cause this to be 0, because you cannot divide by 0. Just set it equal to 0. So what we say then is we have to say x cannot equal negative 4. So those are our two answers. That's our answer, and that's our answer. Example 2. We now are subtracting because of the minus sign. And then again, we're going to identify any x values for which the expression is undefined. Again, when I look at this rational expression and I look at this one, they both have the same denominator. So that's going to make it really nice. So I'm going to write that down here. So I like to put it like that. And now I'm going to put everything together. So I'm going to take the 3x squared minus 5. The tricky part here is that minus sign. We have to distribute that minus sign to each of the terms. So it's going to be a minus 2x squared, a plus 3x, and a plus 2. Back on example 1, we didn't have to do that because we're adding. But when you're subtracting, you have to distribute the minus to each term in the numerator. Again, let's just go back a minute. Remember, when you're adding or subtracting just basic fractions, the denominator stays. It's a common denominator. Stays 5, stayed 7 here. And we just add or subtract the numerator. We are doing the same thing here. The denominator, they both have the same denominator, 3x minus 1. and we are subtracting everything in the numerator. Okay. So I have 3x squared minus 2x squared. That's x squared. I have a 3x, and I have negative 5 plus 2, which is a negative 3. And now we have to figure out what x value will make that equal to 0. So let's just do that over here. We add 1. Divided by 3. So when x is 1/3, the denominator will be 0. So we have to state that x cannot equal 1/3 because we cannot divide by 0. That makes it undefined. Okay. To add or subtract rational expressions with unlike denominators, we first have to find the least common denominator. The least common denominator is the least common multiple of the polynomials in the denominators. A lot of information given there, but I'm going to go over an example how to find the least common multiple. How we're going to go about this is we're going to factor each polynomial completely, and then we're going to write any repeated factors as powers. And then we're going to list the different factors. If the polynomials have common factors, we're going to use the highest power of each common factor. Here we go. Here's how I'm going to demonstrate. This is how you find the least common multiple. This is what I'm going through these steps right here. So I'm going to factor each one of these. Three and 1, because they're the only two numbers that multiply to 3. And we have to add to a negative 2. And we have to multiply to a negative 3. So one of these signs have to be negative. Has to be this one, because negative 3 plus 1 is a negative 2. Now let's factor the other one. Three times 2 is 6, and 6 times 1 is 6. But the only one that's going to work is 3 times 2, because when we subtract 3 and 2, we'll get 1. Again, you have to multiply to a negative, so one's negative, one's positive. I'm going to give the negative to the 3 because a negative 3 plus 2 is that negative 1. Factored. Okay, so did we do that? We factored. That is what we need to do. Now we're going on to step 2. So, least, again, least common multiple. I'm going to go through and list everything I see. So for the red, I see an x minus 3, and I see an x plus 1. Then I go down here. I'm not going to write x minus 3 again because I already did, but I'm going to write x plus 2. That is how you find the least common multiple. And that is what we mean when it says list the different factors. And that's what I did. X minus 3, x plus 1. I didn't list x minus 3 again because I already had listed it. And that is the least common multiple. And that's how we're going to go about finding common denominators. We're going to do example 4 in class. I'm going to go to example 5. All right, we're adding, and then we're going to identify any x values for which the expression is undefined. Now, when we look at this rational expression and we look at this one, The denominators are different. So we need to get a common denominator, like we did here, least common multiple. So the first thing I'm going to do is rewrite this, and I'm going to factor the x squared minus 4 into x plus 2, x minus 2. That's always your first step, factoring the denominator. All right, so now as I look at this, just like I did back here after I factored, I listed all the different factors, but I didn't list the repeated one. So right here, to get the common denominator, I'm going to go like this. I'm going to draw one solid line like that. I'm going to first look at this denominator, and I'm going to grab the x plus 2. Oh, this one has an x plus 2. Well, I already used it, so I'm not going to write it again, but then I write x minus 2. That is called the least common multiple. That is the common denominator. So now what we have to do, we have to go back up and look at each one. So I'm going to look at this one first, and I'm looking at this saying, oh, what do I have to multiply this denominator by to get our common denominator? What is this missing that this has? Well, it's missing an x minus 2. So I have to multiply the top and the bottom by x minus 2. So I have now the x minus 2, x minus 2 times x plus 2. There's that. Plus, well, look at this one. This one already has the denominator, so I don't have to multiply this by anything. I can just go like that. And now we just finish simplifying. We have our common denominator. So x times x is going to be x squared. X times negative 2 is negative 2x minus 8 all over x plus 2, x minus 2. And we're not done because I can factor the numerator and simplify this. Isn't this lovely? All right, there's the denominator. So we have x. 4 times 2 is 8, but it has to be a negative 8. I'm going to give the negative to the 4 and the positive to the 2 because when you add those, you get the negative 2. X plus 2 in the top, x plus 2 in the bottom. So our final answer is x minus 4 over x, whoopsie, x minus 4 over x minus 2. But we have to also specify where it's possibly undefined. And remember, we go back to before we cancel anything. So we're going to be looking right here at this denominator. And so we have to state that x cannot equal negative 2 and 2. Because negative 2 in there will make that 0. 2 in there will make that 0. And that is it. Example 6, class. Example 7, we're going to say for class. Do the video questions. Number 1 is pretty straightforward. The common denominator, they already have one. And here you're going to find the least common multiple.